Hey everyone. So recently I have read a lot of papers on the AI agents, especially after the development of the GPT-4, and this is an interesting field. So I want to have some overview of the paper I read, so it can help to understand the current development and also limitations of the AI agents based on the generative model. So the first part is introduction of the GPT-4, what it can do, what it cannot do. So we could have understanding. The generative AI agents are using GPT model. So that's why I'm going to have a review of GPT-4 first. An overview from the Microsoft research. The title is Sparks of Artificial Intelligence, General Intelligence. From their research results, you can watch it from YouTube on the link there. It seems like the GPT-4 is capable of the multiple aspects of the intelligence, but one of the weakness is the planning. And the other weakness is a bit not as severe as planning, is learning quickly and learn from experience. The planning part, however, it seems like a linear plan is feasible, but something discrete and discontinuous plan, that's when the model having more trouble with. And for learning quickly, we're able to teach something new in one session, but because the model weights are frozen, so next session, the taught new stuff are gone. And from here, we can see the model using it seems like using greedy process generating the next word. So that's when the problem of the incremental task that are solvable in a lot of cases. And there are discontinuous tasks that are not able to solve by the GPT-4. We'll show those cases in the later part of this slide presentation. So from our understanding of what's the limitation of the GPT model is, the paper also propose interesting solvable architecture proposed by Lecan. And then the model seems to doing well on the so-called the fast thinking part or the system one. But it misses out the slow thinking, which is more careful and as a critique of like the fast thinking part. And this is Lecon's model from the brand, and you can see the Earth and the actor. Where the blue circles part, that's where the fast thinking modeler is. It seems like the GPT-4 is able to do it well on that part. So from the paper, it is continue to propose what on the big picture, what we need to resolve. I highlight the part I think is very important. I made them both. So I think the long-term memory, continued learning, personalization, and the planning conceptual leaps are important. The rest, of course, are also important for future development of the model. But in those cases, with let's say with the GPT model at our hands, and also what can we do right now to enhance the intelligence of it? And then so that's where they propose there should be like a external class of tools, a slow thinking mechanism that can oversee the model, so it can have a better planning, and the integration of long-term memory, a context vector. They propose a context vector addition to the token, and the go beyond a single word prediction. You hope to have a hierarchical structure of the higher concepts, so you might have a better grasp of like what's need to be achieved. And in the design of the agents, that's where we're going to review a few other papers. They already designed the generative agents, and let's see how they perform. The first paper is generative agents interactive simulacra of human behavior. So I designed a virtual world with the different AI agents in it, using the GPT model as like a backbone, and then they interact with each other in a small village. It's an interesting paper. The architecture of agents for each agent is like this. So agents perceive, and then they turn into the memory stream, and then agents are able to retrieve the memory based on relevance and its importance score. Based on that, they do the planning and also they reflect. And then from there, they act based on those. So the three key components from their design are memory and retrieval, reflection, planning, and reacting. The memory part, it maintains like a comprehensive record of the past experience. The reflection part, they call it like a higher level, more abstract, reflects on the memory. And then for the plan, they need to have a detailed plan on what to do at specific location, etc. Oh, in addition, the model that you were using are all mostly based on GPT. So another paper I find very interesting is this paper, the Emergent Autonomous Scientific Research Capability Large Language Model. So it is basically a chemistry, and then they designed the GPT-based model and able to perform the chemistry. You can see the results of like asking on the actually in the lab. The model perform, understand, after giving us instruction, we search from the web, search the documentation, code it, and then be able to control and make the real results. Quite amazing. This is their architecture. The central of the architecture of their agent is a planner. And they have a web searcher. They have also a code execution part, a doc searcher, and the experiment to handle with the API with the lab. Like two highlights of the web searchers, like increase the accuracy part, the ability to connect to the, let's say, internet, or able to for the reaction database, and analyze the previous statements, finding out what's going on. Those can improve the performance of the web searcher, also for the planner as a model as a whole. And then they also have the API to have new information to add. That's the doc searcher. So they're able to search for the documents, random documents. And they're also able to use that for finding relevant functions and able to produce a code and feed to the planner. So planner would, in this case, is more like a centralized control. And the rest of them are helping and feeding the information to the planner. One thing they find is that the agent is able to correct its own code based on the outputs. It's quite amazing, self-improved based on that. So for those are the two recent agents paper, based both use GPT-based model to create agents. And what we find the commonality for those are, well, first one is a planning. Well, in more like the acting more or less like a word model. Two of the agent design all involves the planning. And in addition, some kind of memory system, then they act on that. But for this model, we can see that most of them are text-based perception. So the feedback, or you can see the code feedback from like able to correct that. That's also part of the perception modeler. The other part is the specialized modeler for the actor. It's like it acts as a coder, doc searcher, and such part. The GPT modeler, they add a little bit of web searcher. There are some attempts for the MORD model. It seems to work, at least for the chemistry case. So one of the most interesting component I hope to, let's say, to investigate is a plan. How to increase the complexity of planning and the correctness of the planning. Instead of having just linear planning, can we have something more complex, like Eureka moments, and able to be more like a human? Or let's say how to approach to the slow thinking process. One of the case study from the Sparks of Artificial in General Intelligence, which is a paper from Microsoft Research, is like this. So they asked the model whether it can give a short poem where the first sentence and the last sentence, they have the same words, but in a reverse order. So the example they gave is like, I saw her smile in the morning night, morning light as a first sentence. And the last sentence should be light, morning the in smell, her, saw, I. But it's not grammatically correct, so they want to figure out whether model able to do that. But from their experiments, even after the guidance, the model failed to generate something cohesive or comprehensible with that. And then what they conclude is it's a lack of planning in a general sense, because as a human, we would think, oh, what would the sentence fit more like that? Like a sentence that the reverse order and also makes sense. And we thinking backwards to use that to compose a poem like that. They try to give some guidance, but the early version, at least, the GPT model failed to do that. So considering this, there are actually 2 papers regarding to increase the planning of the GPT model. One is a reflection. So after each action and the environment, the model evaluates a heuristic, whether it should have like a rethinking or reflect the action or not. And if it does, the model will try to ask the model to correct that. The other part is called like large language, let's say, language model can solve computer tasks. So it's similar to that, but instead it divides into 2 levels. So it gives like a reflection or critique of the model. So for the plan, it gives like find the problem. What's this plan is wrong or about? What are the problems? And the model will give some proposed solution. Oh, here are the problems, here are the solution. They use that to add to the existing output and then correct the output based on the critique they have, and in order to improve the model performance. In addition, they might also have received code feedback to have those and include into the critique to improve the model performance. So is there any way to solve this based on those techniques? What I tried with ChatGPT based on the GPT-4 model, for the second with the critique version, is like this. I asked the generated poem based on the same prompts of Microsoft Research, and asking it to review your previous answer and find problems, like same technique the other paper used. Those are the results you can see on the left side. In silence, we walked under the moon. But the results they gave is under the moon, we walked in silence. Sure, they're in the same words, but not exactly the reverse order. And then the result it generated after the review the answer and find the problems is like, we walked it can generate the sentence, but it is not not really the exact comprehensible, grammatically correct. Moon the under walked we, silence in. So in addition to that, I experiment myself with more human guidance on slow thinking part. So I break it down on how the human would do that. So ask the GPT model, what's the global constraint? Yes, I answered what the global constraint is, and then find a sentence to fit the global constraints, and it does do that. So it does that well. They breaks gently as birds sing sweetly, sweetly sing birds as gently breaks sky. And then you use the sentence to compose a requirement and able to do that. What's my takeaway from here is that there might be more human structured mindsets, break down the task, and then teaching the model step by step on explicitly define what are the global constraints, what needs to be done with the global constraint first step, then how to then go back to the entire task, how to generate the whole task. So instead of going like forward, it's more like going backwards from the expected results to deal with that. And this is possible maybe with externally adding structure to the model, agent able to do that. The other one I experiment is to use the Google search directly, give the ability to Google search. Because since the chemistry paper inspired me, it seems like their Google or web search adding with the model, planner model together, it helps to improve the accuracy. So maybe a better model, a better version of the word model, attempts to do the word model is to just using Google search. So I feed in with the first web results after generate the poem on the left side, and the search how write a short poem where the last sentence and first sentence have the same words but the reverse order. I just copy all the web page and feed into the model after generating that. It's surprising. I think it's like the model able to do that, and it does generate the results quite well. So although the poem is a bit different since it doesn't feel the constraint the left one, and then but the right is much clearly fits into the guideline, and we can see that like a sunrise paints the sky, and eventually although there's extra I mean have the sky paints sunrise. So we can see like it does the results quite well. So my takeaway on the planning is like short, how to have it a better slow thinking method, have a better word model. It's possible with some example on the human guidance. If we have some human mental model to do the task and able to help the model to explicitly define instead of like greedily search for the next possible words, we can have different version of like break down the task and doing it in reverse or find other ways to deal with it. Then I think the model able to do that. In addition, combined with Google search, it's like the existing global constraints are already broke down into the possible steps or are having examples model could understand. So the model able to do it just like directly with the following instructions. And for the next step is to develop a better memory and a better actor model for the to help with like agents, more intelligent agent AI, and then more. And that's it for the whole presentation. Thank you.